Hey, today we're going to talk about 6.8, solar energy. So take a moment, check out the Enduring Understanding, look at the learning objectives, pause the video, review the essential knowledge, and set up your Cornell notes. So, solar energy is just energy that comes from the sun. And globally, these are the leaders in global solar power generation. China's number one, United States is second, Japan third, and Germany, which is kind of a shocker. Germany is actually fourth place. It is a world leader. And it's really interesting because Germany is not a very, you don't think of Germany as a really sunny destination. So this goes to show you that you do not actually need to have a sunny Arizona or Florida type environment in order to be a world leader in solar panels. You just need a government that supports it, and you need assistance in constructing solar power plants and solar panels. And we'll talk about that throughout this video. In the United States, typically our solar energy comes in the southwest, and this is for obvious reasons because it is very sunny down here and we have a lot of open space. And there's different types of solar energy, which I'll discuss, but it's very low population density over here in this part of the United States because we have vast amounts of deserts. So it is, a really great spot to construct solar power plants. So there's different types of solar heating or solar energy, and we have passive and active solar heating. And one form of passive solar heating is a solar oven, which basically you're using a bunch of foil and you're directing the sun's rays to heat up your food. So you can make a solar oven. You can actually do this at home. You can make something where you can cook a hamburger, you can bake a cake using a solar oven. And this can be done very easily with materials that you have in your own home. Another thing that we can use, we can have passive solar heating in our housing design. So one of the things that we want to do is we want to have, for passive solar heating, we want to have a roof that extends out pretty much farther than normally would. You want to have south-facing windows as well. Because in the summer, the sun is going to be shaded by the roof, so you're not getting direct sun's rays in your windows in your house. And the trees also, if you have trees that are planted, will provide extra shade. So if the sun won't be shining in and adding to the overall temperature of your housing, which can lower your air conditioning costs in the summer. Now in the winter, because of the position of the sun in relation to the Earth's tilt, we do not get direct rays. In the summer, we'll have more overhead direct sunlight. In the winter, it's a little bit farther south appearing. And that is better because when you have winter sun, if you have large south-facing windows, it's going to permit the incoming insolation, the solar radiation is going to be permitted to come into your house and heat up your house. Also, if you have thick floors that are made up of something that will absorb thermal energy, like concrete, it will absorb that heat and then re-radiate it throughout the house. But also, you also have the trees. If you have trees that are planted in your yard, the trees in the winter are going to lose their leaves, which will allow a lot more sunlight to pass through. And in the winter, you're not really impacting the amount of sunlight coming in by this roof that hangs over, because the sun is in a much different position, so it allows a lot of that energy to enter the house. Now, active solar heating, one example is a solar water heating system. And the reason that I know that this is an active solar heating, and this is all that you really need to know, it's got a pump. Pump means active solar heating. So you would have a solar panel that's on your roof, and the sun is heating the water, and then the water just flows down into your boiler or your tank. And this would be a storage tank for your hot water, and it's sending this water to the storage tank where it's replaced with cold water. There's a lot of information in here. You do not need to know all of this. The only thing you really need to understand is that it has a pump. Active solar heating involves a pump. Again, you're using a solar panel on your roof, and what you're doing is you are allowing that water to be heated. So another form of active solar heating is CST, or concentrated solar thermal electricity generation. This is using a series of mirrors, and typically this is done in the desert where we have wide open spaces. And we're using mirrors to focus the sun's energy on a particular point, at which point they will focusing the sunlight, and then they're going to cause water and convert it into steam, which that evaporated steam will then power a turbine and then power a generator and generate electricity in a much similar way than with the other methods that we've already discussed. Another type of active solar heating is using a photovoltaic cell. Now this is completely different because we do not have a turbine, we do not have a generator. This is a completely different system. It is a photovoltaic system, and we're activating and releasing electrons. Basically, when something gets excited, and the electrons in the excited state, if you remember that from chemistry, have a lot more energy, and we want these high energy electrons to this is what's generating what produces the electricity. So you have some sort of semiconducting metal, and in this case it's going to be silicon, and it is going to absorb the energy again and release the electrons, and it's going to generate low voltage electric current. So you're not going to be able to use high demand electrical devices. Like, would not be beneficial for industry, but you can use it to power your electricity needs in your own home. Now, a panel that is west facing in the United States is going to produce the most electricity at peak times because it's going to gather the most direct sunlight. Another thing is, if you have panels that follow the sun, that will produce even better production of electricity using these photovoltaic systems. So there are some benefits to photovoltaic energy or solar energy. For starters, you don't have any emissions during the operation. When you're operating these, there's no CO2, there's no greenhouse gas emissions. They can also produce electricity during the peak demand. In other words, when the sun is at its highest, when the temperature is the highest, you're generating a lot of electricity because the solar energy is very intense. So it can actually help offset the air conditioning electricity requirements. And it's actually economically feasible. So it might take 5 to 20 years to pay this back. The solar panels are very expensive, but after you pay them back, it's basically free. So it's going to take an initial investment, which is maybe a drawback, but then once you pay it back, you get free solar energy. So if you want to live off the grid, solar energy is probably your best bet. So some of the drawbacks: the service is intermittent. You're not going to get great service if you don't have good sunlight. For the large-scale solar farms, the concentrated solar thermal technique, you will be destroying a lot of habitats to facilitate the generation using all those mirrors. The photovoltaic panels are expensive. They're expensive to manufacture, they're expensive to install, they're expensive to maintain. And also you have any of those costs are incurred by the homeowner, which is kind of a problem currently. If you have less solar radiation, for example, if you live in a cloudier area with less solar radiation, you're going to have longer time to pay this back. And the manufacturing is going to require a lot of water and a lot of energy. And fossil fuels are consumed in the creation of these solar panels. And any sort of mining impacts are also incurred here. Mining for the silicon, and you have to mine it and you have to refine the silicon. So that is also a drawback. So for FRQ practice, I just want to talk you through this. We have 3 different types. This is a graph showing the time of day and the amount of electricity generated. We have full tracking. we have a west tilt, and then we have a flat panel. So I want you to explain the relationship between a solar panel's ability to track the sun and its energy production. I hope that this was informative. I thank you for your attention, and I will see you soon.